and we're going to discuss Solana. We're going to discuss what's going on with Solana, how we can build on Solana. Let's say that you're an Ethereum developer. How can you transition into Solana and try it out, and what's possible? How is it different from Ethereum, and so on and so forth. But Anatoly, welcome to the show. Please tell us a bit about yourself, how you get into Solana. Have you been developing on ETH before? How was your journey to Solana?
Awesome to be here, man. I've heard your show. It's like one of the best developer shows out there. So super excited to be here finally. So I'm an operating systems engineer. Spent most of my career at Qualcomm. I was there from like 2003 days. If you guys don't know what Qualcomm is, it's the company that builds chips for almost every phone out there. And I worked on every OS under the sun. These really weird ones like Brew, like QNX, and then more common ones like Android and like Windows and things like that. So that's really like what I'm good at is operating systems. And 2017 rolled around, and as the legend goes, I had 2 coffees and a beer, and I was up till 4 a.m, and this thing popped in my head that you can encode passage of time as data. I couldn't find the right folks at Stanford, like Dan Bonet, that were building these things called VDFs at the time, because I didn't know what to Google for. And I thought it was brilliant, and like came up with something so unique that I had to quit my job and go start a company. And that was it. That was really like, the story of how I got into it. But really, in these initial days, I thought that blockchains and smart contract platforms, I thought of them as operating systems. And I thought the coolest part about it was the censorship resistant piece. And while I was working at Qualcomm, I had been trading on interactive brokers and these like really cheesy Forex trading systems that always screw you. And I've kind of like, I would build these models that would always fail. And that was my experience, was that like, I felt like the other guy that I was trading against was always a little faster than me and always had better data. And like, I couldn't get there, right? I couldn't get to that kind of access. So in those initial kind of visions for what Solana could be, my slides for the first deck said that Solana is blockchain and NASDAQ speed. Because I thought that if you have censorship resistance, we're not talking about store value kind of censorship resistance, but we're talking about like information flow, like classic and general's problem. If I send a message into the system, it's guaranteed to arrive to everybody that's participating in the network. And that access, nobody can stop me from getting access to that information. It's really a trading system, right? At that point, it's like market information, positions, right. All this other stuff is being broadcast to everybody. I thought that if I build that, then I at least have the same kind of access and level playing field that the best market makers in the world do, that pay millions of dollars to NASDAQ to get that privilege. But we could do this with just like open source software and hardware. I thought that was pretty cool, like a cool idea. At the time, people were telling me that DEXs are dead. Ether Delta was like what was best in class and it was pointless. Finance is going to kill everybody.
Yeah.
Like our best investors were telling us that maybe it's not like the thing that we should focus on, but we persevered, built this awesome thing, and here we are.
Well, and at what stage did the FTX come in? Because my understanding is that they're heavily involved. So because it seems that you had your own journey and then somehow they came in and you started to collaborate. How was that?
Yeah, we were lucky enough to have some common investors between us, some really early seed level folks like Chris McCann and Edith Young they're seed level investors. They will like look through the rough edges of the team, people that are like, really don't know what they're doing, but they can see that gem and like nurture it. And they're awesome people. So that we had them as investors, including like Kyle from Multicoin, and they're always telling us, you guys should work with FTX because they're awesome too. And that was really what they were kind of looking at, is that you're both like good teams that are executing. Once we launched, that conversation just went a lot smoother. We showed them this demo of like, okay, here's a very dumb screen. It's break.solana.com. You can just smash your keyboard. And when you smash your keyboard, every keystroke sends a transaction. It's super cheap and they get confirmed. And you can just try to spam the network and it works. And that really opened up their eyes to what's possible. And they're like, okay, now we can build central limit order books. We can do all the stuff that was impossible before. And they threw, like their best engineers, the mythical Gary and Sebastian. And like 4 weeks later, there was a central limit order book.
Nice.
And
so is that what is Serum today? What they started building?
Yes. Yeah. Serum is a central limit order book. It's a really complicated thing to build. So it took some experts like this. These are the kinds of technologies that like you need one or two people that know exactly what they're doing, and you lock them up for like a couple of weeks and they crank it out.
And so but with current way that Ethereum works and the way Bitcoin works, you're never sure that your transaction will be included. You're never 100% sure that it will be in the correct order. Miners can switch it. Miners can take your gains for themselves and extract value. Yeah. But with Solana, it seems that the way you started, when you wanted to have equal playing field for all traders in a system where nobody has extra advantage over someone else because they have better information or connection or whatever. So it feels that Solana is built to solve that. So is that correct?
Yeah. So the thing is that it's an impossible problem, which is what makes it fun, right? So, so the way we approach it is that as a system, so first of all, propagating the information that we can kind of achieve as blocks and data is produced, it is simultaneously transmitted across the entire set of validators, no matter how large it gets. There's no sharding. We just blast this thing out in like this real-time BitTorrent-like way, with a bunch of erasure coding to guarantee like this arrival everywhere. So that bit of it, if I just connect and I just want to watch the markets in real time, just like Gem Trading does at NASDAQ, that's achievable by everybody in the world with no stake. You just plug in and connect to the cluster and you get that data. The more stake you have, though, the more blocks you can produce. And that's where I think these things become kind of interesting, that me as a block producer, I'm kind of running that exchange for those small amounts of time, like 400 milliseconds at a time to get some percentage of the blocks. So it doesn't matter how much stake I have. If I have 100,000 of the current stake, I should get 1 out of every 100,000 blocks. And that's about 1 block per day. So even with that, I can already build a use case where, hey, you want to daily average into crypto? Send your paycheck to me, right? Every day, I will go daily average you. I guarantee you that nobody else is going to front run you because I have that block. And that's nice. That's good enough, right? That's good enough for somebody that's like a totally hobbyist that wants to start and see if they can build a product that doesn't get front run by all the big guys, right? Even for that short amount of time, right? There's no perfect solution that allows everybody in the world everything, right? Like you gotta.
but I think what you're saying is that because there is no mempool that is publicly available, because on Ethereum I can see mempool, I can see this guy is trying to do this and that guy is trying to do that, and I can try to front run. Here there is no mempool, but you know that if you are connected to a node that has a certain stake, they will be able to publish a block. So if you use them, it will work. So that's interesting. And in terms of the building on top of Solana, here's where I think most people that are watching this are very interested, because in crypto you always have new frontiers. Just a year ago we did not have a Binance hype or Matic hype, and now everyone is building on Binance and Matic, and of course now we're seeing more and more on Solana. And Solana really became on my map, at least with Serum, which we already mentioned in this call, and we're still missing that explosion like we've had with Binance or Matic, where the average crypto DeFi user does something on Solana every day. So what do you think is missing for that to happen?
It was just what happened with Binance and Matic is that because it's VM compatible, it was easy to copy and paste some code and start a product. And that's a very powerful thing, right? Like if I can take a proven framework, this is what drives NPM, JavaScript. This is a huge driver of development in Web 2 world, is that I have all these frameworks. I can easily just refactor them and build my own version that tweaks some parameters. There's dangers to that because sometimes people tweak the wrong parameters. But for the most part, it's awesome. Like this is something that was missing. But the benefit that we had is that because it's not EVM, everything is built with Rust from the ground up. It's designed for this central limit order book use case. You can just build different things. And it just took more time for developers to start building those frameworks. But you now see like equivalents to what you see on Matic and Binance that are organically growing, like Saber in like its 1 week of running just hit 200 million TVL. And this is not a copy paste, right? This was built from the ground up. They have their own vision. And that to me is like, okay, this is cool and real and sticky. And these teams that are popping out of our hackathons are able to drive their own product market fit without us trying to throw a bunch of SOL incentives or something like that to get like the big DeFi blue chips to move over. So that organic growth, I think, is like awesome. But
and now
go ahead.
Sorry to interrupt, but I think now I saw that there's also EVM on Solana. Something I saw just this week, right?
So I'm an operating system builder. There's no way I'm going to build something that isn't on an OS. And the way that EVM Neon works on Solana is it's implemented as a program. Solana programs are compiled with LLVM Rust toolchain. They compile to executable Linux format ELFs. So we have a sysroot that is able to run and host these things. It's a full OS. But it is more like an embedded operating system because it's still a blockchain, right? We're still constrained. So it took about a year's worth of work for them to take Sputnik, which is a Rust-based virtual machine, and refactor it so it can run in Solana such that Ethereum transactions can execute in parallel and they can span more than a single Solana block. So you have this virtual machine that's effectively like a running service, right? On this weird operating system called Solana, just like Java runs on Unix, right? And then you can feed it data, right? You can feed it data and it cranks forward and executes just like, this is the world computer, right? Like, I hate to say it.
But the way I think about EVM is kind of like JavaScript. And let me explain. JavaScript is very old. And from the beginning, it was this, not serious, some kind of kidsy thing. But then Google made a nice engine. More people, started to do it. Now it's very nice. It's a bit faster than most. I mean, it's so optimized, so nice.
Yeah.
And the same thing with EVM. It started, Vitalik did, and his team did EVM. But it's a world standard for financial applications now, on crypto. No question about that. So I think it's going to be like, maybe in the 10, 15, 20 years, maybe we still built on EVM, but it's on Solana because the underlying engine is different. So that's very interesting that it's moving that way.
And it's not so much that it is, but at the same time, it's no different than running .NET or Java on an operating system, right? The thing is that like the central limit order book, that stuff probably will always need to be written in native, right? In Rust, that compiles basically to native code. And that's important because you need to squeeze out performance. But if you're talking about like, here's Yearn with a bunch of vaults that are managing a bunch of investments for something like that, let that run in EVM, let it like plug in through a driver call effectively to Serum, to a bunch of stuff that's high performance that market makers are dealing with. And that's awesome. Like, to me, that's kind of like best of both worlds.
Yeah, so if I build on top of Neon, I can then also access like, is that what you said? I can also access like Serum, right?
Yeah, we probably need to like, you're going to run into like, I need this library like I do in Java to access some Windows 32 API call. So you have to do that kind of grunt work, but there's a community that will do that grunt work for you, but it's not sharded, right? It's in the same memory. It's in the same state. It's literally like in the same computer.
So okay. So EVM is then like Java, and then it can access like specific OS-like features like Serum and other Solana. So that's fascinating. And like I told you before the call, we run Moralis, and our vision is that if somebody wants to build EVM, they can build on any EVM. They can sync all transactions across all EVMs with what we're building. And so if we are to implement Neon as one of the EVMs, is it that we run a Geth node, like modified Geth Neon node, or how would that work? Or is it different?
No, you run a Solana node, and there's a proxy thing that is a trustless proxy. What it does is it takes an EVM transaction and figures out what state and like how do I encode and execute it on Solana? And anybody can run this thing, anybody can run the proxy, and anybody can crank it once it's initialized. But you need to like do this weird computation where I have this generic virtual machine, but Solana is not generic. It's like, here's a page table and some memory and some executable code, and go figure out what memory you need when you need it. Like, you're the developer, you're smart enough to do this.
But so on Neon, I'm trying to understand, can I connect to it with RPC and WebSocket like to Binance or Matic? That I can do. Okay.
Yeah, there's the proxy provides a Geth-like API, like a Web3 API that matches what you expect.
So instead of running Geth, I'm running some kind of proxy that is pretending to be Geth. And okay, so basically what we need to do is we need to run and sync Solana node, and then we run this proxy that works like Geth. And it will, because what I'm also trying to understand, will it be plug and play? Because Matic and Binance, it's almost plug and play. There's some parameter change in Geth, but with this proxy, because it behaves like Geth, then it is kind of plug and play, right?
Yep. Yeah.
Very nice.
And
fantastic.
I mean, like in theory, like you could run your own Matic effectively, or your own Binance Smart Chain as another instance of Neon.
Exactly. So because Solana can run anything, but can it really run? I mean, if I have something huge, terabytes and terabytes of data and gigabit per second back and forth, I mean, what can it handle? At the end of the day, it's this distributed network, right? So it has to be some limit.
So it depends. Benchmarks, right, dude? I came from a hardware company. We love benchmarks. So if you have the demand for it, right, like, and you need that capacity, what needs to happen is that the validators that guarantee that 2/3 of the network can come to agreement on it, they need to have that capacity provision. And if there's actually demand for this, they can go get the hardware, they can upgrade, they can ask their data centers, give me 20 gigabit right now instead of 1. And that's an elastic operation, right? It's not like you want to provision the maximum amount of hardware all the time and pay for it when nobody's using it, right? Like, as soon as the demand starts kicking up, people start deploying bigger systems. And we see that kind of going depending on who needs what, right? There were some projects that needed like 100 million of accounts to move into the network. So a bunch of validators went and got a bunch of SSDs, and that happened, right? Like when Serum launched, everybody upgraded from like these 16 core systems that we launched with to 64 core or above. Nice. It just kind of happens because this is what the validators love to do, right? This is their gig, right? And our job at the software level, at the OS level, is how do we make sure that when there is a team that's like, we're getting, 100 million, like we're like Facebook growth. 2 million people are joining a week, right? Like we need this shit like moving like and upgrading as fast as we can. How do we make sure that the software can handle that new hardware? That's really everything we're doing day to day.
But so for us, for our use case, where we want to offer nodes as a service or APIs like as a service, or SDK service, we don't necessarily need to be a validator because we just need the reading of the data and syncing. So do you have to be validator to run a node?
No.